Hello everyone, welcome to my StudyTech YouTube channel. Today I am going to demonstrate how to use Stringtie tool to make the expression profile like FPKM and the count matrix from the BAM file. So here I have two BAM file which was generated by the SRA file, then converted into the fastq file, and then I made this BAM file with the help of HiSat2. So now we need the Stringtie tool. So go to the Google and type. So go to the GitHub page and open it and download this. Let's download it. So download is complete. Let's extract. Extraction done. Go to the Stringtie master, and to install it, open the terminal. Let's see the content, and then you have to type make release and enter. Well, the installation is done, so let's clear it. Let's check it. So here is the list, and you can see the Stringtie in green color. So let's check it. /dot and Stringtie and enter. So you can see the usage of the Stringtie. Okay, just clear it. If you face any problem with this make release code, you can use the alternative command make j4 and release. Okay, come to now. So we have two BAM file here and one Saccharomyces cerevisiae East GFF3 file. So let's just move to the Stringtie here, and let's make the expression of this BAM file with the help of this GFF3. So let's check the file. So here is the file, and this is the cerevisiae GFF file. Let's clear it, and you have to /stringtie and -p. P is the thread, and it's 2, and then I'll use E for expression and capital B for Ballgown output. So Ballgown is the downstream tool to make the differentially express analysis. So I'm making this, and then after that I will use capital A to give the file name. This is the entry name, the ID, and txt file. It will be the output of the expression, and after that I have to use the genomic file, the GFF file. So it is serifc gff3, and then come with the output, and the output file will be same as the file name 83 and gtf. And now you have to put the input file name. So input file name will be this 83 accession 83.bam. So it is the total script. Then I'm going to press enter. Okay, it is done. So let's check the list. So here you can see the list is comparatively long. Here is the some file, this one, and let's say it's check it in directory this and this. Let's copy the output file. Okay, copy it carefully. Don't shift any the program file from this directory. Okay, and I think all is done. Let's cut it, and I'm going to make another result, and in result I'll do the first sample 1, and I'm going to paste it here. So it is the output from the sample 1. You can check this file like this one. It is showing the FPKM value, some coverage, length. Okay, if it is not too visible, so what you can do, you can just copy and open the Excel, not Excel, the LibreOffice, and paste it. Okay, this is fine. Now you can see the FPKM value of each gene. Here is the gene name, I guess. Yes, here is the name, here is the gene ID also. So it is the file. You can check all other file like this one. It is also showing the FPKM value and the TPM value. You can paste this data into the Excel sheet. Okay, so let's do it for the second sample. So I am just changing 84 file, this one, and there is 84, and all is fine, and enter. Okay, done. Let's check it again. So select this file, okay, select it carefully. Okay, here is the 80, this one, 1 2 3 4 5 6. Okay, there is a text file, I guess. What is the text file? And this one, cut and result, making the sample 2, and I'm going to paste here. So here's, I missed one, this one, just cut it. It is the sample 183. Okay, so all is done. So you can see you can get the FPKM and TPM value from here. To get the count matrix, you have to do one thing. Here is the link of this tutorial. I'm copying and go to this link, and down here you can see, if you are using the DSEQ or AJAR as a downstream DEG analysis, so here you need this script, the prep DE. This is a Python script. Open it. So it is the total script, so just Control all and then copy, and then go to here, create a new file and name this file as a prep de.py for Python. Okay, let's paste all the script and save. So close it. So here you can see it is making the Python script here. Okay, so here is the Python script, and here is your result directory. In the result directory there is sample1 and sample2. In the sample1 here is this type of file. So now to make the count matrix, go to the terminal from this directory and let's check it, the list. So here is the list. So to make the count file, write Python. I am using Python 3, so you need to install Python 3 in your system. Let's check it, and then this prep de py, and I for input will be the result directory. So it is the small script, and I'm going to press enter. So all is done. Let's check it. So you can see here is the new file, this one and this one. This is the gene count matrix, and here is the transcript count matrix. Let's check it. This one and this one. This is already the CSV file, so you can check it. Okay, so here it is the count file for the sample 1, it is the count file for the sample 2. So I used only two sample 1 and sample 2. You can generate all other matrix with this script. So it is the whole tutorial to make the count matrix and the FPKM profile from the BAM file with the help of the Stringtie. I hope it will help you. So thank you for watching, and please subscribe and support me with your like, comment, and also by subscribing to my channel. Thank you.